Okay, Kyle, so for the last thing was for number 20, and it wants to do a regression line and then correlation coefficient. And we'll do regression line first. And what that means is just graph this stuff and just draw a line that fits pretty good and then do your y equals mx plus b. So if you were going to do this, I would set it up like this, where you'd have to do like 48 and then 52 and then 60, 65, 73. Like, make that as best you can evenly spread out, and then you would have, like here would be 350. Oh no, it starts here and goes the other way. So it'd be 350, then like 342, 335, 315, and 308. And then you would have to plot those things as best you can. And with these numbers, they're not real great. Hopefully, on your test, maybe you get numbers like that look like they'd work a little bit better. But anyway, with best we can, I have 350 and then 342, 335, 3. So I go like this. And then I need a y equals mx plus b for that. So, well, y is just y, x is just x, plus b, this is 48. So that's really not when x equals 0. That's not when x equals 0. We'd have to go way back to what it would look like way over here when x equals 0. So the way that I would do this is find the slope. So pick 2 points, and m, which is the slope, is your rise over your run. In this case, 350 to 308, my rise is actually, it falls 0.42, and the run from 48 to 73 is 25. So that would be your slope, and you'd put that in there. And then what you'd have to do for this is then take a y value like the 350 that matches up with the 48 and put that in for x. And then use all that to find out what b is. And then go back to y equals mx plus b. But again, these are bad numbers. So what I'm going to do is I'm going to go back and do number 19, because I think those numbers are a little easier to follow, and we can try something with that. Alright, so here we go looking at 19. So we're going to plot this stuff. And so here we have 1, 2, 3, 4, 5, 6, 7. And then at 2, I'm going to make these like 10, 20, 30, 40, 50. And then at 2, it's 12. At 3, it's 19. At 4, it's 24. At 5, 32. 32. 6, 34. And 7 is up here at 45. So again, what we're going to do is make our best line that we can that kind of goes through this stuff. And plants, turnips, I don't know, like that. And again, now we want y equals mx plus b for this line. So y equals x, we know, plus b. Our y-intercept looks like it's 0. Crosses right there at 0. And then we just need to calculate the slope. So the slope, I'm going to say it's 6. It looks like it's close to 40. So remember, the slope is rise over run, which rise is 40, run is 6. So that can be reduced to 20/3, and put that up in here, 20/3. And it's positive because it's a rise. So that would be your regression line equation. The correlation coefficient is showing how close this is, but I think as far as what you're doing, all they want is that positive correlation, negative correlation, or zero correlation. And since it matches up and down, that would be positive correlation. If it went down like this, that would be a negative correlation. And if the stuff was all over the place and didn't seem to make any kind of pattern, that would be zero or no correlation. So hope that helps. You can send me a text or even give me a call if you have questions. Bye.
Dad.